As the world races towards cleaner energy solutions, hydrogen remains at the center of global efforts to decarbonize heavy industries, transportation, and power generation. Over the past few years, governments and corporations have committed unprecedented levels of investments into hydrogen infrastructure, production, and technology, with the expectation that hydrogen will become a critical pillar of the future energy landscape. However, this transition is not without challenges. The cost of hydrogen production remains high, infrastructure is still in its infancy, and regional differences in energy strategies create complexities in market development. So in today's episode, I'm going to explore some of the most significant hydrogen developments shaping the industry. I'll examine the European Union's move towards centralized hydrogen procurement and its impact on global hydrogen trade, groundbreaking carbon conversion technology emerging in the UK, and the economic and technical factors behind Georgia's $33 million hydrogen truck refueling station, South Korea's bold initiative to use nuclear power for hydrogen production, and Australia's acceleration into hydrogen-fueled commercial vehicles. And I'll also discuss how these developments are influencing investment decisions, technology adoption, and supply chain strategies. All of this on today's Hydrogen Podcast. So the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. Before I get started today, I wanted to let everyone know that from March 31st to April 2nd of this year, we'll be heading to Houston for the 4th annual World Hydrogen North America Conference. This is one of the biggest hydrogen events in North America, bringing together industry leaders, policymakers, and innovators to tackle the biggest challenges and opportunities in hydrogen. Not only will we be there conducting a series of interviews, but I'm also honored to be moderating 2 panels. So if you're attending, be sure to stop by and say hi. One of the biggest topics on the agenda this year is scaling hydrogen infrastructure. How will we take the projects and policies we've been talking about for years and actually implement them at a commercial scale? Another focus will be the impact of U.S. policy and incentives on hydrogen investment, especially with new federal funding and tax credit developments shaping the industry. And here's some really great news. If you want to attend, we've secured an exclusive 20% discount just for our listeners. Use the code PODCAST20 when you register. Just head over to worldhydrogennorthamerica.com for more details. We can't wait to bring you insights from this conference, so stay tuned for interviews and coverage straight from Houston. I'll see you there. And so to start us off today, the European Union's plan to launch a joint hydrogen procurement mechanism in September of this year represents a major shift in how hydrogen is bought and sold across the continent. This initiative is designed to aggregate demand for multiple member states, allowing the EU to negotiate more competitive bulk pricing while ensuring a stable supply. Given that the EU's hydrogen demand is projected to reach 20 million metric tons per year by 2030, with at least 10 million tons expected to be imported, the success of this strategy could determine Europe's long-term position in the hydrogen economy. Now, from an economic standpoint, centralized procurement offers several key advantages. By acting as a unified buyer, the EU can leverage its market power to secure lower hydrogen prices, potentially reducing production costs that currently range between 5 and 9 euros per kilogram for green hydrogen. This approach also mitigates financial risk for producers, providing long-term revenue certainty that can attract additional private sector investment. The European Hydrogen Bank, which has been allocated 3 billion euros in funding, will play a crucial role in subsidizing early-stage projects, further accelerating market development. And despite these benefits, challenges remain. Europe's reliance on hydrogen imports, particularly from North Africa, the Middle East, and Australia, raises concerns about supply chain security and logistical costs. Transporting hydrogen in liquid form or as ammonia adds an additional 1 to 3 euros per kilogram to the final delivered cost, depending on distance and transportation method. If European policymakers fail to balance cost reduction with energy independence, could the region become overly dependent on external suppliers? Next, in a significant technological breakthrough, a UK-based company has developed an innovative process to convert methane into hydrogen and solid carbon, providing a commercially viable solution to both hydrogen production and carbon sequestration. This advancement has the potential to reshape how industries produce hydrogen, offering an alternative to both traditional steam methane reforming and electrolysis-based green hydrogen production. The company, Levidian, specializes in methane pyrolysis, a method that heats methane to high temperatures in the absence of oxygen, breaking it down into hydrogen gas and solid carbon without generating carbon dioxide emissions. This method is more environmentally friendly to alternative conventional SMR, which emits roughly 9 to 12 kilograms of CO2 per kilogram of hydrogen produced at $72 to $96 per MMBTU. In contrast, Levidian's process eliminates CO2 emissions entirely by capturing the carbon in solid form, which can then be repurposed for various industrial applications. The company's proprietary Levidian Loop system is a modular, scalable methane pyrolysis reactor designed to be deployed at natural gas processing facilities, landfills, wastewater treatment plants, and even agricultural sites where methane emissions are prevalent. These systems can convert fugitive methane emissions into valuable hydrogen on site, reducing both emissions and fuel transportation costs. Unlike traditional carbon capture and storage, which requires complex and expensive underground injection, the loop process converts carbon into a usable high-purity graphene. This graphene can be incorporated into advanced materials, batteries, electronics, and even concrete, providing additional revenue streams and making the process economically attractive. So from an economic standpoint, methane pyrolysis presents a cost advantage over green hydrogen. While green hydrogen production costs currently range between $4 and $6 per kilogram, due to the high cost of renewable electricity and electrolyzer inefficiencies, methane pyrolysis can achieve hydrogen production costs as low as $1.50 to $2 per kilogram or $12 to $20 per MMBTU when utilizing existing natural gas infrastructure. This price reduction makes it competitive with blue hydrogen, which costs around $2 to $3 per kilogram, but with the added benefit of avoiding the energy-intensive carbon capture process. Now, Levidian has already secured contracts with major energy firms and industrial partners, including National Grid, BP, and Tata Steel, to deploy its loop technology at key facilities. The company is also in discussions with government agencies in the UK, the European Union, and the Middle East to integrate this technology into national hydrogen strategies. Next, the state of Georgia is making a bold move into the hydrogen economy with the development of a $33 million hydrogen refueling station for heavy trucks. This facility is part of a broader initiative to establish a nationwide hydrogen trucking corridor, which will provide a crucial refueling hub for fuel cell-powered freight vehicles. Hydrogen truck refueling stations require significant capital investment, with small-scale dispensers typically costing between $1.5 and $2 million per site, and large-scale commercial stations like the one planned for Georgia exceeding $10 million in developmental costs. However, financial modeling indicates that as more hydrogen trucks enter the market, fuel cells revenue will drive profitability. The hydrogen station is projected to support hundreds of trucks per day, with initial hydrogen fuel prices ranging from $6 to $8 per kilogram. From a technical perspective, the station will feature high-pressure storage tanks and refueling infrastructure capable of delivering 700 bar or 10,000 psi hydrogen, ensuring refueling times of less than 15 minutes per truck. Several major trucking manufacturers, including Nikola, Toyota, and Hyundai, have already secured agreements to supply vehicles for the corridor. So if this project succeeds, could Georgia's model set the stage for a national hydrogen trucking network in the U.S.? Next, South Korea's ambitious hydrogen strategy includes leveraging its existing nuclear power infrastructure to produce hydrogen via high-temperature electrolysis. The partnership between Korea Hydro and Nuclear Power, or KHNP, and Norwegian hydrogen company Nel seeks to develop a highly efficient electrolysis system that utilizes nuclear-generated heat, significantly improving energy efficiency and cost-effectiveness. Economic analysis suggests that nuclear-powered hydrogen could achieve production costs as low as $1.50 per kilogram or $12 per MMBTU, a significant reduction compared to green hydrogen from renewable sources, which currently ranges between $4 and $6 per kilogram. The constant output of nuclear reactors eliminates the need for expensive energy storage and grid balancing, making nuclear hydrogen one of the most stable and cost-effective production methods. With South Korea committing $3.9 billion to hydrogen infrastructure development by 2035, This initiative could provide a blueprint for other nations exploring nuclear-powered hydrogen. And lastly, Australia's Pure Hydrogen is accelerating the transition to hydrogen mobility by deploying a fleet of zero-emission commercial vehicles. These hydrogen-powered trucks are designed for logistics and freight operations, featuring 350 to 700 bar fuel tanks and ranges of up to 500 miles per refueling. The economic case for hydrogen trucks is improving, but cost parity with diesel remains a challenge. Currently, hydrogen truck total cost of ownership, or TCO, stands at 50 cents to 75 cents per mile compared to 40 cents to 60 cents per mile for diesel. However, with declining hydrogen production costs and government incentives, analysts expect these figures to converge by 2035. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.